Hello everybody. My name is Jeff Field and this is Stephen Parente, and we're going to be talking about PubSub on Kafka at Blizzard, or you must construct additional pipelines. I'm Jeff Field, a senior systems engineer on Blizzard's global data platform. This is Stephen Parente, a senior software engineer on our global data platform, and that's Magni Bronzebeard. The first thing we want to do is give you kind of a short history of Blizzard's data pipeline. And first we want you to think about what kind of data does a game company need. For us, there's really three main categories into which the data we gather falls. The first is game balance, so that's like meta-analysis of Hearthstone, which decks are the most powerful, which decks are the most fun. Raid balance in World of Warcraft, is a boss too hard, is a boss too easy? And then there's player engagement, which are various metrics around, are our players having fun? Are they staying engaged? Are they logging in every day? Or is there particular activities that they enjoy more than others? And then the last is operational insight. Being a live service, our games are always online, and so we use that to gather data on service availability, network quality, and capacity planning. Particularly as we move into the cloud, capacity planning has become extremely important. So first I'm going to go over what we call BI API. This was Blizzard's first data pipeline, and we built it using existing technologies that the company was already familiar with to make it easier for the game teams to adopt. Game teams are always kind of reluctant to add yet another library to their game for performance reasons or any number of other reasons. So they had already implemented RabbitMQ and protocol buffers, so we decided to build a data pipeline on top of RabbitMQ and protocol buffers. Later, and this was the subject of last year's talk, we retrofitted that pipeline with Kafka. Now previously this pipeline was only queried using streaming MapReduce or Elephant Bird, and now that pipeline is ETL'd via Spark into Parquet. And then is queried via Hive and Impala. Some of the downsides of BI API are that the first is that it's schema on read. So they send us data, and then optionally later we receive the schema. And so sometimes we could have terabytes of somebody's cat pictures, and we would never know what was in there just because we have no idea. Another downside is what we call schema over Outlook. All of the schemas for BI API existed within the repositories for the games they were from. So there was no central location for them, and if you wanted the latest version of a proto, you would email the game team and ask them to send you the schema via email, which obviously doesn't scale very well. And then so BI API was a good start, but it was built entirely for a batch-driven world. The schemas themselves were large and complex, and the events that were actually being sent with the schema were large monolithic event summaries, such as every event that happened in an entire Hearthstone match would be one single event, which could be enormous. For the launch of Overwatch, we built what we call Telemetry V1. Telemetry V1 was focused primarily on operational analytics, and it contained both client and server data. This was the first time that Blizzard actually had any real telemetry on our client data. Prior to this, the way we would find out something like whether Comcast had gone out in Topeka was that we would get customer contact on that, and then we would have to dig through it. So this was the first time we were able to actually do things like heat maps of latency across the globe to see if we're encountering problems with like a particular network path. Some of the wins were that we had near real-time availability of both client and server data in Elasticsearch, which greatly increased our operational awareness. This also enabled real-time alerting via Beam, not that Beam, which is our internal alerting service. Some of the downsides were that the schema design and the data format made it impractical to utilize for long-term analytics. It wasn't structured at all. And then the other downside was that by having a hyper-focus on operational insight, we actually kind of allowed our gameplay analytics platform to stagnate because we were so focused on the operational side of things. So after Overwatch launched, we took lessons from both Telemetry V1 and BI API and created what we call Telemetry V2. Telemetry V2 is what we called a whole company platform. It wasn't just for a specific game, and as a matter of fact, it wasn't just for games. It was available for marketing, for web services, for anything that the company needed to be able to gather data on. It was built as a scalable microservice architecture, and it was logically organized into 5 data paths, which were ingest, enrich, process, store, and access. Some of the wins we got from this were that it was now highly structured and with a schema registry, so we could immediately, if somebody was looking at a message, we could actually say, oh, I can definitively go in, read the comments on the schema, and know what they're sending, because oftentimes the name of a field has nothing to do with what's actually contained inside it. It was also far more performant, meaning that it required a lot less compute. I think that when we deployed V2 and deprecated V1, we used something like half of the total compute globally. A fourth of the compute globally. Thank you, Stephen. Some of the issues were that while it wasn't as focused on operational data, most of the data still being sent to it was operational data, even though it would have been just as good for gameplay data. And our highest volume data was actually server metrics. The other problem is that we were too strict on the data format. This was somewhat of an overcompensation for what we did with V1, where we didn't really require much structure at all. And so what we've learned since then is that there's a balance between them, that unstructured and semi-structured data do have a place in our data platform for certain use cases. And here we're kind of just going over pipeline usage. BI API is, even though it's technically deprecated, if anyone's still playing our 20-year-old games, you know we're not very good at deprecation. BI API still really receives a lot of data, and the data is, per message, much bigger than Telemetry V2. This is because the bulk of BI API is those summary messages I told you about. It's, you know, all of the messages contained inside a single proto for a Hearthstone match, or an Overwatch match, or a StarCraft 2 match, or an entire raid in World of Warcraft as one event. For Telemetry V2, you can see that we have many more discrete message types, and this is because we've kind of worked with developers to focus on, instead of sending all of the information for an entire game in one swoop, send us the individual items as they come along. Part of this is just because joins have gotten a lot less expensive on our data platform than they were 5 years ago when we were using base 64 encoded protobufs in Hive. And the other is that for a lot of our applications now, it really doesn't make sense for you to sift through half a megabyte of data when you just want to know, which skins did they have. Not all data in V2 actually ends up in HDFS now. We take the, and this is just the HDFS numbers. We also put time series data into Cassandra, and then we do have certain events that the game teams send that are really only relevant in real time and that they don't want to do long-term analytics on. And so those events just go to Elasticsearch, and then when the TTL expires, they're just gone. So we've gotten a lot of value out of our existing pipelines, but both BI API and Telemetry V2 were heavily focused on batch analytics and on batch analysis and long-term analytics. In the past year, several use cases have emerged that require lower latency access to data that customers are already sending through the pipeline. Two examples of this revolve around what we call disruptive player behavior. Disruptive player behavior is an industry-wide problem in gaming. And beyond just banning players, we want to encourage positive behavior, such as through the commendation system that we've implemented in Overwatch. When an action must be taken, the closer to the original incident, the more impact the action has on long-term player behavior. If you do something mean in a game and then you're banned for it 3 days later, it's not nearly as impactful to you. We've trained models by having employees categorize disruptive chat. You'll often see people at Blizzard going through disruptive chat logs on their lunch break to help categorize them, which is exactly what you want at lunch. Currently, these events are handled in batch and require human intervention. Ideally, we would like to do this automatically and in near real time. The other use case we have is what we call risk forwarding. Play nice, play fair is one of our core values at Blizzard. And some of the events that we receive through both of these pipelines revolve around cheat detection, such as suspected hacks in Overwatch and unusual trades in World of Warcraft. In both of these cases, quick action is better. A quicker action in World of Warcraft limits the impact to the game economy of something like duping or of account selling and things of that nature. And quicker action in Overwatch helps preserve player enjoyment by ensuring that they don't have to, if there is a player misbehaving, they don't have to see that player 4 or 5 times in a row.
So with that quick history, we still want to solve those new use cases by allowing them to be accessed in real time. It's not good enough for us to have this batch processing or to forward things daily over to our teams on risk or global insights. We actually want to be able to get this data to them quickly and give them a good way to consume this data. So how do we build a platform to enable them to do that? We already have something that is pretty good at collecting all of the data, but we just need to actually send the data out somewhere else from the other end, rather than just keeping it in the self-contained ecosystem we've developed for these game teams and the supporting teams. So there are a few challenges to that approach at first. The first one is, as we talked about a little bit before, the data culture has shifted to this operational culture rather than the business intelligence culture. People started sending a lot of operational data, like things like network quality and things of that nature, in order to better debug our players' problems, and so that we could find them before customer service reported it to the game teams. And we've gotten a lot of really good value out of that. But we need to get people to send business data again, because it's actually really useful to be able to read that data in real time, and it provides the ability to do really cool use cases like the 2 that we just showed. We have these 2 production pipelines, which is another problem, or just a challenge. We have a lot of data in this BI API pipeline, but because the requirements are very different for sending data there, we can't just do a one-to-one port and kind of merge those 2 streams exactly together. So that is just another thing that we need to keep in mind as we go about solving this problem. Centralization is another thing that we want to help our teams not have to worry about so much. So we are deployed regionally. So every single region our games are deployed in, whether that be Korea or China or the United States or Europe, we have data pipelines there collecting that data, and that is so that we can have as low latency as possible as we collect the data, and also provide as little impact as possible to the game servers that are actually running and sending this. So we don't want our consumers of this data to have to worry about that. If you want to consume the stream of data that's coming through all of our pipelines all at once, because there's some really good use you have for that, whether it's training an ML model that is language agnostic, being able to provide a centralized platform to be able to run that would be really useful to the teams. Isolation is another thing we definitely need to consider, because at Blizzard, game teams kind of run very independently. They share code between one another, but they act with very different direction, and they have very different tech stacks. Because of this, they're very used to being able to only depend on themselves and the supporting teams when we provide a good service that they want to leverage. But we don't want there to be a blast radius large enough for one team to knock out some feed of data that another team wants to consume. And the last one we talked a little bit about before is latency. The batch jobs latency was too high to tolerate for some of these new use cases, and we definitely want to make sure that we deliver the data in a good amount of time as we move forward, providing a new solution. So with that in mind, there's a few core concepts for how we can get data to be consumed in this way. The first, I like to see it as we want to filter the data coming through all the pipelines, forward the data to the centralized location where people want to consume these feeds, and then isolate those feeds from one another so that our customers can consume data, even a copy if they need to, and never affect another customer. So for filtering the data, all of our data pipelines kind of just collect a large fire hose of data. That data can go through different paths through our pipeline, but it's all kind of aggregated into these very large fire hose topics in Kafka. Not every single piece of that data is actually ever going to be useful to consume in some sort of streaming job or even as a pub sub forwarding use case, because a lot of it actually only matters to the teams that put the data in there, and maybe it's only relevant operationally or just long-term to make reports. So we need to filter that subset of data down to something more manageable, especially if we're shipping it through the network from a data center to data center. Forward is the next logical step there. So after we get this thinner stream of data filtered down, we want to be able to forward it somewhere central so that it can be consumed in a unified place. Then last, we need to be able to isolate it. So Kafka has really good partitioning, and we've made really good use of that here. And the way that we can do isolation is either by broker, where we have multiple clusters of brokers, or by topic. So one message might be produced to several topics just to ensure that there's isolation for each stream. So here's the Telemetry V2 architecture again one more time. And this is kind of where the isolated data path comes in really handy for us to be able to make extensions here. So we have this process layer, which is anything that is post-enriched. And when I say enriched, it really means that we've processed this kind of raw data that's through ingest that has not been validated, and we've ensured at least that it conforms to some level of structure, really that it's been enveloped. So anything past that has that guarantee that at least there are types that it can leverage. Maybe it's not the payload, but for us to be able to add this new feature to our pipeline, it's just a matter of treating it as a separate processing layer. And here we have our stream filterer. So the filterer can read this large fire hose of all the data. As you see, all of our enrichment data, even for log enrichment, can be piped into this filterer. And it can read that and be able to match any messages that need to be forwarded down to the streaming platform for pub/sub use cases or streaming use cases. And it stores them in Kafka as a store rather than something more permanent like HDFS. So it can be accessed in real time. So within that platform, this is kind of the access layer that we've established. So rather than something really simple like just, oh, use SQL and query the data, the access pattern we're trying to encourage with this platform for pub/sub use cases or anything that requires kind of complex streaming jobs, this is the way that we want our customers to access it. So it's an engineering service that we're trying to provide. You'll see the data pipeline is in the top left, and that there can be many of them. There's one for each region. There could be more than one for each region, depending on how we've had to isolate the games from one another or any team that's reporting this data. That gets sent to a Kafka, which is a centralized Kafka, and we use Mirror Maker to do that. And then once it gets there, it goes to a job called the stream splitter. This is going to read this stream of filtered messages from every region, and these can be deployed one per region, even if it's in the central location. But it reads that stream of data and ensures that if two customers are looking for the same piece of data, it can make sure to isolate using topics or brokers on the other end, isolate that feed of data into that location. So as we see here, we have 3 different topics that are a unit of isolation here. And these could have some of the same messages or completely separate messages from one another. And then Kafka allows us to agnostically consume this data, so we can read it in Flink or Beam, or what we call canned jobs. And canned jobs are especially useful, I think, because a lot of these teams don't really want to write Flink or Beam. In fact, there's not even that much Java expertise outside of our team. So canned jobs allow them to do pretty simple things like forward from broker to broker, and then you can consume on the other broker on the other end. Or maybe something really simple like send to an HTTP service, and then ensure that they have a server running and we'll just send them the data as it comes and they can do what they need to do to it. This will all be managed through a UI, and this UI doesn't just manage Flink and Beam and the canned jobs that we have running, but it can also manage the rules APIs. Those are going to be sent federated to every region, so each region collects the data that our customers are asking for. So Kafka's role in the platform has been very significant. I mean, besides being like every single arrow in all the diagrams, it's also provided us some really nice abilities like compacted topics. We've been able to use compacted topics really successfully for our rules because when we store them in Kafka, we can consume them all from the beginning to warm a cache of rules. They're very small, so it's very easy to store them all in memory. And also we get instant notifications when a rule has changed. So the filters immediately know that they need to be reading different data or not reading data that they used to be reading. Data partitioning by topic or actual partition is absolutely critical for us to be able to provide the isolation guarantees we want to provide in our platform. And the buffer cache reads are very important when we talk about latency. So Kafka, as long as you're reading at the end of the topic or where you've been reading before, you might never have to actually hit the disk to read that data that you're looking for. It could come directly from memory and just sent right off to you, and then you could consume it with much less latency, with less I/O. And blue-green job deployments are very important for our customers as they want to iterate. We want to provide a holistic dev experience as we have this platform. So we want people to be able to make different versions of their code that could act on the same data and maybe do something different with it, so they can test their changes before they go to the real production environment, or potentially go to production in parallel as you turn the other one off, like in a blue-green deployment. So how does this help solve the problems that our fellow teams were having in something like disruptive player behavior? So the Global Insights team wanted us to be able to feed them chat data in near real time so they could pipe it through their machine learning models and be able to detect if the behavior that the player was exhibiting was disruptive or not. So they needed really low latency because one of their requirements was they wanted to be able to action these accounts very quickly. So by using Kafka and the platform, we've been able to establish those low latency requirements, especially when they were used to once a day on a batch job. So huge gains there. The single centralized deployment has been really helpful for them because they don't want to have to worry about deploying their jobs in multiple locations and then have to worry about data in one location being very different than the other. They can actually just have everything piped through a single stream. And we can also support supervised actions. So our GI team is actually using Flink, and they can join the stream of events that we're already collecting for player reports or even our customer service approving an action with the actual chat. So we can make sure that we pipe the chat through a machine learning model. We could detect if we think that this is disruptive, send it to customer service, listen for the response, and then immediately actually do the action all automated if we need to. But once we have enough confidence in our ML models, and I think we're actually very close, we might not even have to have CS in the mix except for potentially later use cases down the road. And for risk forwarding, they were just kind of a pure pub sub use case, so it's even more simple. They just want to be able to take data that they want from our pipeline that previously they've only been able to access through our other access layers and have that forwarded to their location. So we can actually provide that with just a canned job that does this. So they use broker-to-broker forwarding. They have a Kafka cluster that they manage themselves, and they have a consumer that pipes it into their log analysis system. So it's very easy for us to be able to have a subset of rules and say, send all this data to this broker, and then it just can do that, and they can make changes to it anytime they want to start collecting new data, and we don't have to be involved. They also have a single centralized deployment. Their log analysis software is only deployed in one region, so this makes it a lot easier for them rather than having multiple consumers hitting multiple brokers or dealing with broker-to-broker latency or potentially outages. We kind of handle that all for them. And they also require really high reliability. We don't ever want to lose that insight that that team has into what is happening in our games. So because we've built this on our existing pipeline for data collection, we get to start on that established foundation. So what's next? There's still more that we want to be able to provide our customers. The big one that I talked about before is we do have these two production pipelines, and this challenge definitely wasn't met by the architecture that I just showed. So what can we do to help make this even better for our customers? So tapping into legacy data seems like a good place to start. But we can't just do that one-to-one port, so we have to figure out a way that we can start collecting this data and sending it to this pipeline that isn't just blindly forwarding these schemaless messages. So I think the first step there is that we want to destructure these summary events into multiple events within a stream. So an end of raid message in World of Warcraft is every single encounter. So if you wiped 100 times on that boss, we're going to have 100 entries in that array that was sent in one single message. So don't wipe because you save us disk in our warehouse. We could also do this in batch. We already know this is asynchronous, and as much as streaming has been really great for a lot of use cases, we know this data is already not in real time, so we get a lot of good performance benefits, especially when you're using something like Avro potentially to understand the schema when you do it in batch and can consume large sets of it. We also need to embrace unstructured, and Jeff kind of talked about that at the beginning. We don't need all data that goes through the pipe to be structured and sent to HDFS or Elasticsearch, things that do require that structure. A consumer of a stream doesn't, as long as they understand how their data is to be understood, we don't need to understand it. So we need to lessen those strict requirements if we can. And we want this to be API driven. We don't want to make the mistake of compiling every schema in a jar and then using that jar to understand every single message that's sent through the pipe. Like, we want to be able to kind of make mappings in an API and have those rules fetched down and then used to interpret the data and then send data in an unstructured way, maybe JSON or something downstream. There's also a little bit of future platform work we can do just to make it more stable or reliable in general. Canaries are going to be important as these use cases become more operationally necessary. As we get more confidence in our machine learning models and as our global insights team is able to make better use of their disruptive player behavior system, this is going to be operationally necessary for Blizzard to be running because our players are going to expect that it will be working the way they've always expected. So having canaries send data through these pipelines and report information about utilization, about reliability will be really helpful for us to be able to monitor these things. Bad actor detection also gives us some better isolation requirements. Because if a bad actor starts running, even if it's within your own team, even if you're isolated on your own team's Flink cluster, we can actually shut it off if it starts using too many resources so that we can spare the other jobs. And pre-partitioning the data earlier in our pipeline will also give us big wins in performance and scalability later. If that filterer only had to read partitions in Kafka that it knew data might exist on, we could actually eliminate a lot of the overhead of no-opping messages. And here's some key takeaways that I think I'd like to give from my experience. We want to be a carrot, not a stick, and like it has some drawbacks. Like we can't just deprecate our old system and tell everyone to get off. But it also makes our customers have a better experience. So we want them to migrate, and we give them a cool new feature to do so. So they can still use the old legacy system, but there's just a new reason to maybe want to migrate to the new one. You should always partition and isolate your data too. Use cases like this become very difficult if you don't do any data partitioning on your own. So make sure you're doing that as you develop your applications. Provide a good holistic user experience, and this doesn't just mean a user interface. You want to provide a frictionless experience from starting to onboard onto the system and consuming it on the other end. And you always integrate with existing services when possible too. By having all this data already in our system, we were able to provide immediate value without any game team intervention because they were already sending a lot of data that was valuable. And last, and this is close to my heart, don't use the word telemetry to name your data platform because then everyone's going to think it's like ground control for the space shuttle and they should just send you their CPU metrics and memory metrics, which are very useful and we're happy to collect them, but then they stop thinking about those business use cases. And the most important takeaway actually could be the title of the speech, is the alliance is better than the horde. So thank you very much for listening to our talk. Please check out Node-RT Kafka. It was written mostly by yours truly, and it's, I would say, the best way to consume or produce to Kafka on Node, but I'm biased. And we are hiring, so please check out our careers webpage if you are interested. And thank you.
Thank you very much. We have time for a couple of questions.
So first off, Laktar Ogar. But also, you mentioned a couple of your games, in particular Overwatch. I play a lot of Overwatch, but I wondered how exactly you got the buy-in to really drive the process so early. It's always been clear with Overwatch that everything was being adjusted pretty much constantly. Is that driven by the team, or is that more on your side?
So that is very much driven by the team. The game teams are very much semi-independent entities within Blizzard. But also a lot of the kind of culture there had built up over time. A lot of the people that are on Team 4, which is the Overwatch team, came from the World of Warcraft team where a lot of our nascent data platform kind of developed. And so Overwatch is actually an interesting case because it's really the first product that we released that was developed after we had built like a stable, usable data platform. And so it was very much designed with those things in mind, whereas in a lot of cases, for example, in World of Warcraft, most of the messages we receive from World of Warcraft are literally the in-memory object in the daemon gets serialized as a protocol buffer and thrown on the wire. There wasn't a lot of thought given to what is this going to look like in a relational context. And so Overwatch is a great example because it has many discrete messages and they are very focused on the information they actually want to gather instead of just sort of sending everything.
Hey, so it looks like the rules really drive a lot of kind of the core stuff that's going on in your pipeline. So I was wondering if you could just elaborate on what a rule kind of encompasses and maybe what it can and cannot do.
Sure. So I think you're talking about the filtering rules. Yeah. Okay. So the filtering rules right now, there's more that we want to do with them eventually, but right now it's kind of simple, and all they can do is kind of run based on the message name, which is a schema. So every schema has a unique message name in our system, and you could say, I want these schemas. You can actually provide a regular expression so that you could say, I want all of Overwatch's data just by simply using their prefix, because every team has a prefix. There's more we'd like to do because our envelopes actually collect more data than just that. Things like what host it was sent by, what BattleNet ID. So we'd like to potentially open it up one day to being able to query those extra fields. And then eventually even potentially using Apache Calcite to be able to write SQL on top of them and be able to do really rich select statements that can get you kind of any data and even introspect the payload.
Any more questions?
If you don't have questions, we have to sing.
In one of the earlier slides, I saw RabbitMQ and Kafka. Is it for legacy reasons that you have both of them, or does it serve a different purpose?
Okay, so RabbitMQ was part of our initial pipeline, and so the reason we still use RabbitMQ is because that's what, in some cases, the 12-year-old games are still sending over. And so what we do is, in these cases, it used to be that we would actually use like RabbitMQ, have Flume pick it up from the Rabbit, and do like an Avro connector back to the United States from, say, China. But that was incredibly slow and lossy. So what we did, and we gave a talk on it last year, was that we kind of retrofitted all that. We weren't going to get the game teams to stop talking to Rabbit. So what we did instead was that we put a connector in between the two. So the game team publishes to a local RabbitMQ server, and then that data is immediately picked up, published to Kafka, and then goes through the rest of our pipeline like any other message. And that was just a way for us to get kind of the existing benefits of Kafka without having to tell the game teams that they have to, ship a new version of a game that maybe we aren't currently doing builds of.
One last question here.
Hey guys, thank you for your talk. I really like your statement about like good customer experience that you try to offer to your customers, which are developers, right, primarily. And I'm wondering, like, how do you educate them? Because one of the problems that we have at Booking.com, right? So we have an extensive customer base of completely different sorts of developers. One can be more familiar with Kafka than other and whatnot, right? So is it a documentation or internal trainings or videos, cookbooks that you do? Like, how do you do it?
First I'll say is we could definitely do a better job. There's definitely some gaps. One thing that we've used to educate our customers is we have a thing we call TDK, and TDK is the Telemetry Development Kit. So what it will do is kind of spin you up your own little isolated pipeline to dev against, and you could actually make it part of your CI. And our customers will kind of use it and figure things out as they go along, like how they want things to look without risk of making breaking changes later. And they could even send us their TDKs and say, hey, take a look at what I'm sending. Does this make sense? So we try to give them a lot of assistance as we go along because data is definitely hard and they're still figuring it out. In addition, we try to provide interfaces that are kind of more abstracted than something just like produced to Kafka. Like, just write to this HTTP endpoint. Here's an SDK. Like, it's going to make sure that at least some of the things we want everybody to be doing are being done. Things like incremental backoff when our services go down. Things like what we call flow control, which is actually sampling. But we can, so we can kind of control a little bit of their code when they use our SDKs. And we actually have one for like every language Blizzard uses, which is like 12. So there's a lot. But yeah, we'd like to do more, and I think what I would like to do in the future is potentially even kind of POC really cool things they can be doing to show good data culture and inspire them to say, oh, look, if we start sending this kind of data in this way, look at the cool stuff we can do.
Let's see if I can do this without shouting. Yes. One other thing that I want to give a huge amount of credit for is that our particular project has the best documentation of any project I've ever worked on. We have an incredible technical writer that works on our team and works directly with us and focuses on giving that, on writing that documentation for the game teams. And then we just have to actually explain to them that there is documentation because they're not used to that being true.
Okay, we need to wrap up here. Thank you very much. One reminder, we have this Kafka app, Kafka Summit app, so please rate the sessions. And we're having a short break and we'll be back in 10 minutes. Happy gaming.